Today we are going to study the first two sections of the chapter 5, which is the polynomial chapter. But before study the polynomials concept and the operation associated with the polynomials, we need to understand the properties of the exponents, and we need to know also to deal with the negative exponents. And let's move to the next slide to start with these two sections. Then first review what is the concept of the exponent. The exponent refers to the number of times a number is multiplied by itself. If we had 4 to the third, in this case 4 is the base and 3 is the exponent. And this 3 means we need to multiply 4 3 times. As 4 to the third equals to 4 times 4 times 4. And we know this equals to 64. And we need to be careful because 4 to the third is not 12, as 4 to the third equals to 64. Why? Because 4 to the third equals 4 times 4 times 4. Then now we want to discuss the properties of the exponents. And the first property we want to study is the product rule. Then let's try to solve this. What we had here is we had the product of 2 to the third times 2 to the second. And if we apply here the concept of the exponent, and we had 2 to the third equals to 2 times 2 times 2, and 2 to the second, yes, 2 to the second will be 2 times 2. And this will be equal to 2 to the 5. Then now we can see if we add the exponents, we will get the same answer. Yes. Then we can simplify the math. And if we know we had the product, yes, if we know we had the product of the exponent in which the base is the same, then just we need to add the exponents. Yes, we need just to add the exponents. And this rule applies not only if the base is a number, if the base is a variable, also we can do the same thing as we had here. A to the third will be equals to a times a times a. Now a to the second will be a times a. Then 1, 2, 3, 4, 5, then a to the fifth. Yes, and it will be a to the fifth. And again, then now we can use the property of the exponents to simplify this problem. Just we can say if I need to multiply a to the third times a to the second, just I need to keep the base and add the exponents. Yes, and we had a to the fifth. Then in general, we can apply this rule. If we had the product of a to the m times a to the n, then we had the same base. And what we had to do is just we had to keep the base and just to add the exponents. And we can apply this property only if we had the same base. Then we will add the exponents only on like variables, means only if the base is the same. And we can apply this rule either if either the exponents are positive or negative. The important thing is the base must be the same. And let's try to apply this rule, the product rule, to this problem. If we apply the product rule to this problem, and yes, if we had the numbers, we multiply the numbers 2 times a equals to 16. And here I will write all the steps. Then x to the third. Now we need to find the variables that are the same. It's like variables where we had the same base. Then x to the third, x to the second. We had the product. Then now we can add the exponents. Then it's 3 plus 2. Y. We had y to the third plus 5. See, if there is no exponent, then just we know the exponent is 1. It's 1. And see, 1 plus 3. Then we had 16x to the 5th, y to the 8th, z to the 4th. And we can just move from this. We can skip this step, yes? But I want just to show step by step, yes? Because this is the first problem we are doing. But usually we don't need to write this part, yes? If you don't want, you don't need to write this part. And we say 2 times a is 16. We had the same base. And we had the product. We can add the exponents. Then 3 plus 2 is 5. Y. We had y. We had the product. Then it's 3 plus 5 is 8. We had 1 here. Yes, we had 1. Then 1 plus 3 is 4. The next rule is the quotient rule. In this case, we want to solve this quotient, 3 to the 5th divided by 3 to the 3rd. And let's solve applying the exponent concept. Then we will have 3 times 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 3. Then we can simplify this. 3 divided by 3 is 1. Then we can simplify. We can cancel out this and the 3. And then we will have 3 to the 2nd. What we can see is we can simplify this exponent problem just as we subtract the exponents. Yes, we can get the same thing. Just we keep the same base, but just we subtract 5 minus 3. And we had something like that. Then we can apply to this problem the quotient rule, and we don't need to do all this math. Yes, all this math. The important thing is we can apply the quotient rule only if we had the same base. Yes, like here they say we had like variables. Yes, we had the same base. And again, but the base can be a number or can be a variable. And if we apply the same rule, in this case we will have times a divided by 1, 2, a to the 3rd. We cancel out this one, we will have a to the 2nd. And we can apply the same rule and we will get the same result. Then in general, we say we can apply the quotient rule to this problem, yes, only if we had the same base. What we had to do is we had to keep the base and we had to subtract the exponents. Exponents can be positive or negative, but always the rule is we subtract the exponent in the numerator minus the exponents in the denominator. Always. It's this one minus this one. Always we need to apply this rule. Then let's try to apply the rules we already know to solve this problem. And I want to write this problem again. Y times 5 divided by x is y. C. And now let me write here y. And we have 3x to the 4, y to the 6, 5, x to the second, c, x to the third, divided by 2x to the third power, y, and z. Then now we want to solve this problem. Then what we had to do is we can apply the quotient rule, and we can apply also the product rule only if we had the same exponent. Then if we had a quotient, what we will check first is we can simplify the numerator, or if we can simplify the denominator first, yes, and then we will simplify the quotient. Then let's see, can we simplify something in the numerator? We had x here, we had x here, we had the same base, then we can apply the product rule. Also, we had 3 and 5 here, yes, we can multiply the numbers. Then let's try to multiply the numbers and let's try to simplify the numerator. Yes. Then 3 times 5 is 15x. We had x to the 4 here, x to the second, 4. We had the product rule, yes, and we need to add the exponents. Then 4 plus 2 is 6. 2, x to the third, y, and z. Then now let's write here. Then yes, we cannot simplify, we cannot reduce this fraction, then we will write like that. And let's see x, and I will do this one with all the steps. Then we had the quotient and we had the same base. Then we can just keep the base. 6 minus 3, y, 6. Again, if there is no exponent, we know it's 1, then it's 6 minus 1. Z will be 3. Here is 1 minus 1. And let's write here x. 6 minus 3 is 3. Y. 6 minus 1 is 5. 3 minus 1 is 2. And this is the answer. Let's move to the next. The next property is power of a power. And if we had the power of a power, what we had to do is what we will do first is we will apply the concept of exponent. Then we had 2 to the second to the third power. We know in this case this is the base, 2 to the second. Yes. How many times we need to multiply 2 to the second? 3 times, because this is the exponent. Then we will have 2 to the second Yes, this is the base in this case. 2 to the second, 2 to the second. And we know now, if we have the same base, yes, is the product rule, we can keep the base. 2 plus 2 is 4, plus 2 is 6. 2 to the 6. Then what we can see is we can simplify this problem, yes, just if what we had to do is, if we had the product of a, if we had the power of a power, what we had to do is just multiply the exponents. 2 times 3 is 6. Then we can simplify the problem if we apply this rule, power of a power, just we need to multiply the exponents. We keep the base and just we multiply the exponents. And we can do the same thing if we had variables. Then in this case, this is the base and this is the exponent. How many times I need to multiply the base? 3 times. Then 8 to the seconds, 8 to the second, 8 to the second, but this is 8 to the 6 because we had the same base and we need to add the exponents. 2 plus 2 is 4, plus 2 is 6. And we can simplify this problem just if we multiply the exponents. 2 times 3 is 6. Then if we had this kind of problem, what if we had the power of a power, what we had to do is just multiply the exponents. Then in general, if we had the power of a power, we multiply the exponents. But what we had to be careful is with the sign of the exponent, because the m and n can be positive or negative numbers, and still this rule apply even if the exponents are positive or negative. As this rule apply for any number, positive or negative. Then let's try to simplify this. This expression, and we want to simplify completely, as this is we want to do. And let's try to apply this rule. In this case, we had the product of the exponents, but also we had the power of a power. Is really we had to apply two properties at the same time. And remember, if there is no exponents, we know we had one here, we had one here. And one more thing is, everything we need to raise to the second power, everything we had inside the parentheses. It's not only the variables, we need to raise also the numbers. If the number is inside the parentheses, 3 is also to the second power. Y is also to the second power. Y to the third is also to the second power, and Z to the second is also to the second power. And let's try to solve this problem. Yes, let's apply power of a power also. Then 3. 1 times 2 is 2. X. 1 times 2 is 2. Y. 3 times 2 is 6. Z. 2 times 2 is 4. Now we need to simplify completely. Then we need to solve this one. 3 to the second. We know 3 to the second is 3 times. Let me write here. 3 to the second is 3 times 3 means is 9. It's not 6. Yes, it's 3 to the second is 3 times 3 is 9, it equals to 9. It's 9 x to the second. This is the answer. And the next thing we want to discuss, the next property is power of a product. And the power of a product, we had here the power, yes, to this product. And in this case, let's solve this one applying the concept of the exponent. And the concept of the exponent say this, if this is the base, we need to multiply the base how many times? By itself 3 times. Then it's 2 times 3, 2 times 3, 2 times 3, 3 times. But we can write this one like 2 times 2 times 2. Then we can write this like 2 to the third times 3 to the third. Then what this property say is, if we had this problem, what we had to do is we will put the exponent to each factor we had in the parentheses. Yes. Then if we had 2 times 3 to the third, yes, we can solve this one. If we just put the exponents to the third, to 2 to the third, and 3 to the third. Yes. And what we had to do, if we had power of a product, then yes, we had to do is just we need to put the exponent to each factor we had inside of the parentheses. 2 to the third, 3 to the third. And we don't need to do all this math we had here. And again, this property apply also if we have variables. Yes, in this case the base is a times b. Then we need to multiply how many times? 3, because we had is to the third power. Yes. Then here we can write this one like a times a times a, and this is a to the third times b to the third. Then again, if we had this kind of problem, yes, we had power of a product, then what we had to do is we can just simplify the problem if we put the exponent to each factor. Yes, and in general, we can, if we have this kind of problem, what we had to do is we put the exponent to each factor inside of the parentheses. Again, this is valid if the exponent is positive or is negative. We can apply the same rule in any case. Then let's now try to apply this property to the problem we had here. And in this case, what we can do is a is 3 times 2. Let me write here this step b 2 times 2. C means there is no number there. We know it's to the 1 is 1 times 2. Then we are applying really two properties, power of a product and power of a power. Yes, we are trying, and here is multiplication. Just be careful, here is multiplication. 3 times 2 is 6, 2 times 2 is 4, C, 1 times 2 is 2. Then you don't need really to write this step. I am writing here because I think is you can use to know exactly how we got this 6 there, the 6 here. Then, but we can just from this we can move to here. Yes, we can say if I apply the power of a product, just I need to multiply the exponents, and it's 3 times 2 is 6, 2 times 2 is 4, 1 times 2 is 2. One important thing here is we can apply this property only if we had the product. If inside the parentheses we had a product as A times B. This, we cannot apply this rule if we had addition, and also is not true if we had subtraction. Okay, this is not the same. Okay, then it's not true. We can apply this property only if we had the product inside of the parentheses. The next slide is the power of a quotient. And let's apply first the concept of the exponent. And in this case, the base is 2 divided by 3. Yes, 2/3. This is the base. And how many times we need to multiply the base? 3 times. And then 2 to the third times 2 to the third times 2 to the 2 divided by 3, sorry, is 2/3 times 2/3 times 2/3. And now we can write this one to 1, 2, 3 divide 3, 1, 2, 3. And if we had this kind of problem, what we had to do, what we can see is what we had to do is we can put the exponent for every factor in both in numerator and in the denominator. And just we can put 2 to the third, 3 to the third. And just we can do is this one. Yes, we don't need to do this, all this part if we apply this rule. And again, we can apply the same rule if we had variables. Yes, then in this case, the base is A over B. And how many times we need to multiply A over B is 3 times, because this is the exponent. Yes, then we had here 1, 2, 3, and then divide by B to the third. And again, if we had this kind of problem, what we had to do is just we need to put the exponent on every factor, in both in the numerator and in the denominator. Then this is the rule. As this is the general rule. And also this property apply if the exponent is positive or is negative number. And let's try to solve this problem. Then we had 2, let me write here 2y, write again the problem. Then let's apply the quotient rule. Then we had here this will be equal to the second divide by 5 to the second. Now here we can apply the power of a product. Yes, in this case, then we will have. Remember, if we had a number, we need to also apply the property. Then 2. 1 times 2 is 2. Y is 1 also. 1 times 1. 1 times 2 is 2. Over 5 to the second, and if you want, you can write 25. 2 to the second is 4. Y to the second, 25. Yes, and this is the answer. If you get practice, you can skip some of the steps. You don't need to go through all the steps. Then now here, I want to write this one again. Divide by b to the second power. And what I suggest you, if you had a quotient, yes, and you had different factors side of the parentheses, what I suggest you is try to simplify what you had inside the parentheses, and then you can apply then you can rise to the second power. Then in this case we had to apply two properties. We had to apply the quotient rule. We had to apply also the power of a power. And let's try to apply the quotient rule. Then we had A, we had C, but here we had the same base. Then we can apply the quotient rule. Then we had A, and let's do with all the steps. Because we had quotient, we know we need to subtract find the exponents. It's y minus 2, 8. Yes, it's same base, subtract the exponents, we had y minus 2. And we don't, a to the third, 5 minus 2 is 3. And we had to be careful, yes, with this one. Now we need to apply we need to raise this expression to the second power, and I will do here. Okay. Then 3 times 2 is 6. B, 3 times 2 is 6. 8 times 2 is 16. Yes. And this is the answer. We cannot simplify more this expression. Then here we summarize all the rules we have studied until now. Then we had product rule. Yes, we can add the exponents, but just we had to be careful. We can apply this rule only if we have the same base. In the quotient rule, we can apply again this rule only if we had the same base, and if we had the quotient, then what we had to do is we had to subtract the exponents. Power of a power, just we had the power of a power, just what we had to do is just multiply the exponents. It doesn't matter if the exponents are positive or negative, you can apply this rule. The other rule is the power of a product. Then just you can put, if you have the product rise to any power, positive or negative, what you have to do is just you put the exponents to each factor. And the same thing happened if we had quotient or we had division, as we can put the exponents to the numerator and put the exponents to the denominator. Here in this case also the power, the exponent can be positive or can be negative, and we can apply the rule. Then let's try now to solve different problems in which we had to apply several properties. And let's solve the first problem. Yes. Then we had in this case power of a power. Then what we had to do, then now just here is important to remember, this is a common mistake, is if you had a number, you had inside of the parentheses, as like this case, we had to rise to the third power not only the variables but also the number. Then because here 4 doesn't have any exponent, we know it's 1. We know it's 1. And let's apply the rule. And what we had to do in this case, just we need to multiply the exponent. Then 1 times 3 is 3. X. 2 times 3 is 6. Y. 5 times 3 is 15. Because we need to simplify this expression completely. Then we need to solve this. We need to solve 4 to the third. I will just write here. Remember, 4 to the third is 4 times 4. And it's 4 times 4 is 16. 16 times 4 is 64. And this is 64. Y2, 15. And this is the answer. Yes. Then 4 to the third is not 12, is 4 to the third is 64. Then let's solve this number 2 first. And let me write here. I don't have enough space here. Then here is important. You see 7, 8 to the third is not raised to the third power. Just what we had to the third power is what we had inside the parentheses. What we had inside the parentheses. Then we need to apply the rule just to this part. Yes? The power of a power. And we had 1 here. And we don't have to do, just now we don't need to do anything with this part. But with this part, we need to apply the rule. Then 2. 1 times 3 is 3. 8. 4 times 3 is 12. Now we need to simplify this if it's possible. Then what we can multiply the numbers, but we know 2 to the third equals to 8. Yes, 2 times 2 is 4. 4 times 2 is 8. And just be careful with when you are solving this kind of problem. And we had 8 to the third, 12. It's 7 times 8 is 56. We had the same base. Then we keep the base and we add the exponents. Then we had 15. Yes. And this is the answer. Let's now solve the next one. With this one, again, if we had an expression inside the parentheses, before to rise to the third power, in this case to the power, we will see if we can simplify the expression we had inside the parentheses. Then this equals, let me write here. Then we can multiply the numbers. 4 times 5 is 20. X. Now, because we had here the product, and we had x, same base, we can add the powers. 3 plus 4 is 7. We had y, the same base, and we know here is 1. Yes, then 1 plus 2 is 3. And we need to rise to the third power. Yes, it's to the third power. Now, what we had to do is just we need apply power of a power. Then we know, remember also the numbers. We need to apply two variables and the numbers. 20 to the first power, then 20. 1 times 3 is 3. X. 7 times 3 is 21. Y. 3 times 3 is 9. But we need to simplify this expression completely. Then we had to solve 20 to the third. 20 to the third, I will write here. Okay? 20 to the third equals to 20. 20 times 20 is 400. 400 times 20 is 8,000. Then here will be 8,000 x to the 21 y. This is 8,000. And this is the answer. Now let's try to simplify this expression, and let me write this expression here first. Again, x to the 7 b x to the 4 divided by x to the third second to the second. Then now we had x to the third. Let's see, review x to the 7 v x to the 4 b to the 6 divided by to the second one. Okay, then we had this expression. Then now if we had a quotient, we will see if we can simplify first something in the numerator and if we can simplify the denominator. After we simplify the numerator and the denominator, then we can try to divide the both expressions. Then in this case, what we can do here is we can simplify this because we had the same, we had x and ax, we had the product, as we had the product, and we know x is to the 7, then we can add the powers. 7 plus 4 is 11. Now we had b to the first power, as we know it's to the first. Then 1 plus 6 is 7, and b to the 7th power. What we can do is we can apply in the numerator the power of a power. Then we need to multiply the exponents. 3 times 2 is 6. 2 times 2 is 4. Now we can apply the quotient rule. Yes, now we apply first here the product rule, power of a power. Now we can apply the quotient rule. And we know what we had to do. I will write, let me write here. And x, and in this case we had to subtract the exponent. This will be 11 minus 6, 7 minus 4. And you can skip this step if you want. It's just, you can say x equal x, 11 minus 6 is 5. B will be 7 minus 4 is 3. And this is the answer. Yes, this is the answer. And then let's now try to solve the number 5. And let's rewrite this one. Something like that. We had 2 y divided by, we had something like that here, x to the second power, and all the expression to the third power. Let's check if I don't make any mistake when I write this one. 2y6 divided by x, 8 to the second, this to the second power, this expression, and everything is to the third power. And again, what I suggest you is try to solve what you had inside the parentheses. Let me write here equals. Can we simplify something in the numerator? No, we cannot simplify because all the variables are different. Then we will write this one like that. Now, can we solve something in the denominator? Yes. It's power of a power, and we know in this case we need to multiply the exponents. We had 1 here, then x 1 times 2 is 2. Y, 2 times 2 is 4. Z will be 3 times 2 is 6. Now, and very important is, don't forget the third power. Now we can apply the quotient rule as 2, because we don't have any number in the denominator. Now x, and let's now apply directly the quotient rule. X, 4 minus 2 is 2. Y, 6 minus 4 is 2. Z, a minus 6 is 2 to the third power. Remember, we can apply the quotient rule only if we have the same base. Yes, in this case, the same variable. This is 2. Okay. Now we need to solve this one, and we need to solve also, we need to raise to the third power also 2. Yes, it's 2. 1 times 3 is 3. X, 2 times 3 is 6. In this case, we need to multiply the exponents. 2 times 3 is 6. Z, 2 times 3 is 6. Now we need to simplify completely. Then 2 to the third equal to 8. Remember, 2 to the third is 2 times 2 times 2. Yes, this is 8. 2 times 2 is 4. 4 times 2 is 8. And this is the answer. Yes, we cannot simplify more this expression. Now we will move to the next section, which is the negative exponents. Then let's try to see the next property is called the zero power. Yes. Then we want to know if any number is raised to the zero power, how we can solve this expression. Then let's first apply the quotient rule to this expression we had here. Yes, if we apply the quotient rule, what we had in this case, we will have 2, 3 minus 3. Yes, we had to subtract the exponents. Then we will have 2 to the 0. Then this we had in this case. Now let's try to solve this. 2 to the third divided by 2 to the third. Then we know 2 to the third equals to 8. Yes, because it's 2 times 2 times 2. 2 times 2 times 2 means it's 8 divided by 8 equals to 1. And what we can conclude from these two solutions we had in this case, then we had 2 to the third divided by 2 to the third equals to 2 to the 0. But also 2 to the third divided by 2 to the third equals to 1. Then what we can conclude from this one is these two numbers, these two expressions must be equal. Yes, must be equal. And here we can conclude is 2 to the 0 must be equal to 1. And this works, yes, if also we can apply the same properties if we had variables. As we had in this case, the base is a will be 3 minus 3. This is from if we apply the quotient rule. Now if we solve this expression, we had a to the third divided by a to the third times a times a. Then a divided by a is 1, 1, 1. Yes. Finally, we have this equals to 1. Then we had then what we had is a to the 0 equal to 1. Then what we can conclude from these two problems we had here is any number or expression raised to the 0 power will always be 1. Yes. Any number, any expression raised to the 0 power will always be 1. For example, yes, in general, we had this. Yes, any number, any expression to the 0 power equals 1. And if we had 1 to the 0 equals 1. If we had 100 to the 0 equals 1. We had 3 to the 0 power equals 1. We have 3x squared to the 0 power equals 1. You had a to the 0 power equals 1. Yes. If you had 535 to the 0 power equal 1. Any number, any expression raised to the 0 power equals 1. Then the next rule we want to study is the rule of the negative exponent. Yes, then here this part we had to be careful when we deal with negative exponents. Yes. Then let's apply in the first part, let's apply the quotient rule. And if we have this, we will have 2. We had the quotient, the same base, then we can simplify this one. Just we keep the base and we subtract the exponents. And 3 minus 5 will be 2 to the negative 2 power. Yes. 2 raised to the minus 2. Then now let's solve this one. If we apply the concept of the exponent, then 2 to the third will be 2 times 2 times 2. 2 to the fifth power will be 2 times 2 times 2. This is multiplication. Times 2, 1, 2, 3, 4, 5, one more. And we can, and we had to be careful, yes, because 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is 1. What we had top is 1. But this 2 to the second is, they are in the denominator, yes. Then we had to keep this one in the denominator, and will be 2 to the second. Then again, this expression equals to 2 raised to the minus 2. And the same expression equals to 1 over 2 to the second. Then what we can conclude is these two expressions must be equal. And what we can conclude here is 2 minus 2 must be equal 1 over, this must be equal. And we can apply the same thing, the same procedure if we had variables. Then a, same base, we had quotient, then we had to subtract the exponents, then will be 3 minus 5 is minus 2. Let's now apply the concept of the exponent. We had a to the third is a times a times a times a times a times a times a. Get 1 a to the second. Again, if this expression equals to a to the minus 2 power, if the same expression is equals to 1 over a to the second power, and these two must be equal, as these two must be equal. And what we can say here is a to the second. Then what we can conclude here is if we had negative exponent, yes, if we had negative exponent, and if we want to get positive exponent, what we had to do is we need to move the base with the exponent. Yes. Then how we need to move the base with the exponent? If we had negative exponents in the numerator, yes, this case, what we had to do is we need to move this one to the denominator. Yes, if this is negative in the numerator, just to change the sign of the exponents, what we had to do is we need to move this one to the denominator. If we had variable, is the same thing. Yes, if we had the negative exponent in the numerator, to get positive exponent, what we had to do is move this one into the denominator. Now, if we had the negative exponent in the denominator, to get positive, what we had to do is just move this one to the numerator. And what we had to do is just we move this one in the numerator. If we combine these two properties, then we can apply this one. If we had a, I want to write this one here like that. Let me write here a over b to the, then to get positive, what you had to do is just you had to flip the fraction. And this, and then equals a. I cannot write here, sorry. Cannot write in this part of the page. Okay. And if you had a fraction, yes, to the negative exponent, what you can do to change this, just the sign of the exponents. Just, you see, when we flip the fraction, what we change is just the sign of the exponent. Then to change the sign, just what you had to do is just you had to flip the fraction. Yes, you have to flip the fraction. It's very important that you understand this property when you are solving the problems. Okay. And now let's try to apply this property to this, to solve this problem. Yes. And the first one we had, let me write this one again. Probably I will write like -4. Yeah. Then what happened in the problem and in the test, you need to write the answer after you simplify the expression. The answer must be include only positive exponents. And always the answers must be include only positive exponents. Then this is why is important you know the rule for the negative exponent, how apply that rules. Then we can apply in this case. You see, we cannot simplify really nothing in the numerator. We cannot simplify anything in the denominator, but we don't want negative exponents in the answer. Yes, and what to do is we can apply the negative exponents rule for the in this case. Yes, then we don't need to do anything with the number. Now, if we want to change the sign, and this is in the numerator, just move this one to the denominator and change the sign. If we want to change the sign and this expression is in the denominator, what to do is just move this one to the top and change the sign. And this is the answer. Yes, we cannot simplify anything in this expression, and all the exponents are positive. Then this is we need to do, and this is the final answer. Then I want to solve this problem in two ways. I want to solve this problem using the negative exponent rules, but I also want to solve this problem if we apply the quotient rule. You can solve in either way. Usually this kind of problems you can solve in more than one way, but you should get the same answer if you use either way. Then I want to rewrite this one, and this will be x to the third y. Then now what we had to do, let's apply the negative rule of the exponents. And what we had to do is we can just x to the third, we want just positive. Yes, then we need to change this to move. We can say we had to move the exponents to the numerator or to the denominator, but we want to move in the way we can get only positive exponents. Then this is x to the minus 2. We just want positive, and this is in the denominator, move to the top to get positive. We had y here. This is 1. Yes, we don't want to move this one, but this one is on top. Is y to the minus 3, and we want this one positive. And if we want this one positive, just move to and now I want to write the answer here. And what we had to do now is just to the product rule. We same base, we keep the base and we add the exponents. Y, same base, we add the here I had, let me change this one. Here is to the third. Yes, must be, because it's minus 3, must be to the third, and here will be must be to the 1 plus 3. This is 1, is 4. Then this is the first way we can do this problem. We'll write here the way 1. Way here. Now I want way 2. And you can solve in either way, right? Either way. And let's write here the problem again will be x to the third x minus 2 y. Minus 3. Then let's apply the quotient rule. Yes, let's apply the quotient rule first. And if we apply the quotient rule, will be x to the third. This one minus this one. We have to be careful. This is negative. and is this one minus 2. Okay. Is this one minus this one, but the exponent in the denominator is negative. Y minus 3, remember this is 1, is this minus 1 equals, we know this one negative times negative is positive. Really we had 3 plus 2, then 3 plus 2 is 5. Minus 3 minus 1 is minus 4. But we don't want negative exponent, then what to do? If this is on top, just to get positive exponent, move to the, and we got the same answer. Yes, we got the same answer. And it's just, you can solve in the way is easier for you. Yes, it's easier. Personally, I prefer it this way. Yes, I think it's easier. Then in this slide, we summarize all the properties we study. In this, we include the zero property. Yes, any number, any expression rise to the 0 power always equals 1. And if we had negative power on top, to get positive, just move to the bottom. If we had negative power on bottom, to get positive exponent, just move to the top. If we had a fraction to a negative power, then what to do is just, we can flip the fraction and change the power. Yes, this is what we can do. And let's move to the next. Now what I want to do is, I want to do several problems in which we need to apply all these properties, and in some cases also we need to apply the concept of the exponent. And let's now, always if you had a fraction to a rise to the negative power, just flip the fraction to get a positive power. Okay, always. You see, in this case this is negative, and what we had here is negative 3. Oh, sorry. Negative 3 divided by 5. Then we can write this one like negative 5 to the third power, to the second power. Then what I want you focus here is, we flip the fraction. Because we flip the fraction, we change the sign of the exponent. But we don't change the sign of the base of the number we had inside the parentheses. Just we flip it. We don't need to change that signs. The only signs we change is the signs of the exponent. Now we can apply, I think what we can do here is we can apply the concept of the exponent. Then what is the base in this case is minus 5 over 3. How many times we need to multiply minus 5 over 3? 2 times, yes, twice. Then to solve this one, we have minus 5 times minus 5 over 3. This is 3. It's 3. The negative times negative is positive. 5 times 5 is 25. Here is multiplication, okay? 3 times 3 is 9. Then the answer is 25 divided over 9. Remember how we multiply the fraction is straight across. Yes, 5 times 5 is 25. 3 times 3 is 9. Now let's move to the next problem. Then what we had here, let me rewrite this problem is 2 to the 0 times 2 to the third negative 9. Nine. 2 to the 0 power. Any number to the 0 power equals 1. 2 to the third power, 8. 2 times 2 is 4, 4 times 2 is 8. X to the minus 9. Then we don't want negative exponents in the answer. We just want positive. Then what to do? Move to the top. It's in the denominator. Move to the top. Finally, we had ax to the 9 power. Yes, this is the answer. And let's solve this one. Let me write here the problem. 2 to the 0 power, 1, times b to the minus 3 power. Then we don't want negative powers in the answer. This is in the denominator. To get positive, just move to the top. And the answer is 1 times b to the third is b to the third. And let me try this one again. We had 2 x to the second y to the third divided by then again, if we had a fraction, yes, if we had a quotient, what we will do, if we had a quotient rise to any power, what we will do is we will try to solve if we can simplify what we had inside the parentheses first. Then we can write this one as we can write this one like 2 x to the second y to the third x minus 1 x to the minus 1. Then what we can do, because it's in the denominator, is negative, we can move to the top, but we change the, and will be x to the 1. We don't need to write 1 because we know it's 1, but we need to, let's write 1, and maybe in this way you will remember. Now let's see if we can simplify. We can simplify what we had inside the parentheses. Then we had the same base, we had the product, yes, product of a power. Then we had 2x, same base. Then we can add the exponents. 2 plus 1 is 3, y to the third to the fourth power. Then now we had to be careful with the numbers. We need to rise to the 4 power everything we had inside of the parentheses. Then 1 times 4 is 4x. Now we had power of a power. We need to multiply the exponents. 3 times 4 is 12. Y 3 times 4 is 12. Because we need to simplify completely, we need to solve 2 to the 4 power will be 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And we had 16 y, and this is the answer. And this is the result. And now let's try to solve the number 7. Let's write this one again. Yeah. minus 2 divided by 6. And again, if we had a quotient, what we will try to see if we can simplify the numerator, if we can simplify the denominator, and then we can divide the expressions. Then in this case, we had power of a power. We need to multiply the exponents. Then will be x. 3 times 4 is 12. Y 2 times 4 is 8. X 1 times minus 2 is minus 2. Y 8 times minus 2 is minus 8. We need to be careful. If the exponent is negative, we need to multiply by the negative number. Yes. X to the 4, y to the 6 power. Then now what we can do is we will try to see if we can simplify the numerator. And let's see, let me write here. X 12. We need to add the exponents, but in this case, x, this exponent is negative. And in this case, if one of the exponents is negative, just we need to subtract. This is 12 minus 2 is 10 equals 10. Y a minus 8 equal 0. Probably let me write here step by step. This will be 12 minus 2 will be better. Y a minus 8 x to the 4 y to the 6. Let me write here. And x 12 minus 2 is 10. 8 minus 8 equals 0. Y 6. But we know any number, any variable to the 0 power equals 1. Then we have x times 1 divided by x. X to the 10 times 1 x to the 10 power. Now we can simplify. Yes, we can apply the quotient rule. We had the same base, and what we had to do, we had to subtract the exponents. 10 minus 4 is 6. And here we don't need to do anything. We don't need to do anything with the exponents because all the exponents are positive. Yes, we had x to the 6 divided by y to the 6. Both are positive, then this is the right answer. And now I had here the same problem in one side and in the other side, because I want just solve in two different ways again, and you decide in what way is easier for you. And let's write the problem again. We had minus 3 to the 2. It's 9. And let's solve what we had in the numerator. See, this is minus 3. Yes, this is minus 3. And we had to be careful. It's minus 3 to the second power. Yes, it's not only 3. It's not only 3. It's minus 3 to the second power. We multiply as is 1 times 2. In this case, for a will be 7 times 2 is 14. and we don't need to do anything here. Now, minus 3 to the second power. Any negative base rise to the even power, always the answer is positive. Always the result is positive. But if you don't remember that rule, what I suggest you to do is just you solve equals to minus 3 times. In this case, the base is minus 3. And how many times you need to multiply minus 3? Twice. Yes. And negative times negative is positive. 3 times 3 is 9. Then minus 3 to the second power equals 9. Yes. And my suggestion is always just you solve. Yes. Just you solve the expression. Then minus 3 to the second power is 9. 14, yes. And if this is negative, but we want positive exponents in the answer, and just move this one to the top. A will be to the 20, sorry, will be 9. Let me be 9, 23. And the other possible way you can solve the same problem, and is also by, let me write here, minus 9. And this part will be the same thing, and I'm going to spend more time with this part. Then here we have 9. And that part is, here is negative 9. And in this part, what you can do is you can apply the quotient rule. Then you can say this is 9a, this one minus this one. But you have to be careful, is this one minus 9. Yes. Is this the exponents on top minus the exponent in the denominator is 9. Always is if the exponent in the denominator is negative, you have here addition. Yes, you have to add. Then will be 23. It's the same answer. Then you can solve either in this way, yes, applying the negative property of the exponents, or you can apply the quotient rule of the exponents, but you should get the same answer, and both ways are right. Then we had here the last problem we will solve for this section. And I want to solve the problem in two ways, yes, in the same way I did before, and then you choose in what way is easier for you. Then let's solve this problem first, applying the negative the negative exponents property, and it's minus 2. Let me write this one again. 6 divided by 5 to the negative 2. Then we will try to move the base and the exponent in the way we can get only positive exponents in our answer. And if we had any number we can simplify, we will simplify that number. Yes, for example, in this case we can simplify the fraction. Yes, we had, if we divide by 5, 5 divided by 5 is 1. Yes, on top, and 20 divided by 5 is 4. Now x to the minus 2. But we want just positive exponents, then we can move this one to the top and get this one with positive. Yes. And we had y to the second. Then because we want just positive exponents, we can move this one to the denominator. Is 1 y minus 6. We move to the bottom and we change the exponent to the minus 2. Then now let's try to simplify the numerator and simplify the denominator first. Then minus, if we multiply any number by 1, we will get the same number. Then yes, we need here x minus 2 plus 5 is 3. We have 4 here. Y 2 plus 5, 2 plus 6 is 8. Minus 2. Yes. Now, if we had a fraction to a negative exponent, what we had to do to get positive, yes, we need to flip the fraction. Yes. Then to get this positive, what to do is x to the third to the second by the equal sign. Now we need to solve. Yes. Then 4. You had 1. Then 1 times 2 is 2. Then 4 to the second. Y 8 times 2 is 16. X 3 times 2 is 6. But we need to simplify completely. Then we had 4 to the second is 4 times 4 is 16. Y divide x. And this is the answer. Now let's solve this one. Is we apply the quotient rule. Yes. Then y minus 2. And let me write here. Then we can simplify the numbers. Yes, it's 1 over 4. But in this case, what happened is we will apply the quotient rule. Then what we had is x, yes, minus 2. We had the same base, then is the exponent, the exponents we had on top minus the exponents we had in the denominator. Yes. To apply the quotient rule, we need the same base. And the same thing we can do with the y. Yes. Y minus 6 minus 2. This minus this. But this exponent is negative. I need to get that negative. Then what we had here, again, if we multiply any number by 1, we will get the same number. And here you see this negative with this negative. Always we had the negative exponent in the denominator. We had positive. When what we had is negative 2 plus 5. The negative 2 plus 5 equals to x to the third. Again, minus 2 plus 5. Yes, minus 2 plus 5 is 3. Then x to the third, y. Both numbers are negative. We need to add the numbers together and keep the sign. And here I forget something important. Yes, I forgot this -2, sorry. And here is -2. And if we want to get just positive exponents, what we had to do is we can move this one to the bottom. Yes. Yes, we need to move this one to the bottom. Now, if we want to change this, the negative exponent, we had here, and what we had to do is we had to flip the fraction, yes, to change the sign to the second. Yes, now because we flip the fraction, this turned into the positive. And now the next thing we had to do is just to solve. And I will do here because otherwise I don't have enough space to give the final answer. And 1 times 2 is 2, 16, 8 times 2 is 16, x, 3 times 2 is 6. Then 4 to the second power is 16, y 16x to the 6. And the answers are the same. Yes. And this is all I had for today. Please stay well and bye bye.